Let's take a look at the inversion of configuration that occurs when you open an epoxide using a nucleophile. So I have two examples that I'm going to go over here very quickly. So the first thing we have to consider is the regiochemistry of the nucleophilic attack. And we're going to start with this example here. So when the starting epoxide is unsymmetrical, the nucleophilic attack is going to occur at the less substituted or least hindered carbon. So our nucleophilic attack is going to occur at this carbon here, which is going to be our least hindered carbon. So what's going to happen if we draw the mechanism of this is we have our cyanide, which will be a nucleophile, is going to attack our least hindered carbon, and then our oxygen or our epoxide is going to open up to give us our desired product. So what you can see, the stereochemistry at our two stereocenters. So right now, this stereocenter here is R, and this stereocenter over here is S. So once we undergo our nucleophilic attack, our product is going to look something like this. So the stereocenter where the nucleophilic attack did not occur, so where it did not occur, is not changed. That stereocenter is not changed. So this stereocenter will remain our stereochemistry. But the stereocenter where the nucleophilic attack occurred, it does invert. So you can see that our hydrogen was down. At the beginning it was down, and now it's up. And our nucleophile is going to have attacked from the backside of the epoxide. So we have our nitrile group here. So now the stereochemistry at this stereocenter will be R as well. So you can see that what occurred was inversion of configuration only at the stereocenter where the nucleophilic attack occurred. So I'll circle this. We went from S to R. So again, to reiterate, the only stereocenter that undergoes inversion of configuration is the one where the nucleophilic attack occurred. So let's take a look at this example down here. So again, we have to consider the regiochemistry. First of all, we have two possible sites for nucleophilic attack, but of course there's only one site that's going to undergo nucleophilic attack. So this time I've drawn an alkoxide instead of a nitrile, and it's going to attack the least hindered carbon. So that's going to be the carbon that has the hydrogen or proton on it. So we're going to get our nucleophilic attack here, and our epoxide is going to open up because it is highly strained. That's the reason why epoxides undergo nucleophilic attack. Normally, oxygen by itself is not a good leaving group, but since epoxides are so strained, it will undergo a nucleophilic attack and it will open up. So again, I put water as the second step in both of these. So I'll end up with a protonated compound. And you can see that the stereocenter that did not undergo nucleophilic attack, nothing has changed here in terms of the stereochemistry. 1, 2, 3, 4, 5. So this is a pentyl group. But the other side of our molecule, let's look over here. So here we have our OR group from our alkoxide, but the other side is flipped. The hydrogen that was below the plane, so let me draw a line here, and this is something that maybe we're a little unclear on, that we look below this line here. So now, well actually this dashed wedge should be below as well. So forgive me for my lack of drawing skills, I guess. So now the hydrogen is flipped up. So it's above the plane, and I'll draw this so that no ambiguity will be found. So we have our ethyl group here. So in the beginning, when we started our nucleophilic attack, first we had our stereochemistry here, and we had our stereochemistry here as well. You can see the site that did not undergo nucleophilic attack. This site is R. But this site here has now been inverted, and this now has S stereochemistry. So you can see that inversion of configuration only occurs at the carbon that undergoes nucleophilic attack. And of course, just to review again, the regiochemistry, when the starting epoxide is unsymmetrical, the nucleophilic attack is going to occur at the less hindered or less substituted carbon. Hopefully this helps a little bit.